So this is just enough StackDriver to help you sleep at night. Does everyone want to be here? In the right room? Awesome. So I'm Aja. I'm a developer advocate on the Google Cloud Platform team. But before Google, I worked at a large variety of companies. I worked at big companies, I worked at medium-sized companies, I worked at an early stage startup through their GA for, actually that was 5 years, so through a couple releases. I also worked in consulting for a couple years as well. So I've had a lot of experience doing a lot of different things with operations at different size companies with different tech stacks. So I'm going to set some expectations up front. This is an intro level talk. I'm going to cover the absolute basics of the tools that I wish I had when one of the many hats I was wearing was, oh yeah, you're doing the ops engineering. Oh, and your QA manager and your release manager. Oh, and can you do a little dev work on the side because we're really strapped. So we're going to do the basics today. As part of that job, at the early stage startup especially, I had to carry one of these. Who's had to carry a pager or a cell phone at some point during their career? Come on, hands, yeah. So to this day, the sound that our on-call phone made, that ringtone, will stop me mid-sentence, and then I'll start doing this, trying to figure out, oh, do I have to deal with that? Is that my phone going off? Do I have to go make sure the site's still up? And I hate that. I really hate the fact that I still have that visceral reaction. And that happened because we had a lot of alerts. We had an awful lot of alerts that didn't mean anything. And so I'm really passionate now about helping people set up their applications so that the alerts that they get are the ones that matter, that you get alerts when you can take action about something before it becomes a disaster, because I have restored a database at 2 a.m. That was not fun. And I also want to make sure that no one has to be woken up at night unless something is actually really wrong. So one of the things that happened when I was working at the startup was we had a bunch of different tools. We had 3 different monitoring systems. We had a tool for log aggregation. We had another tool for doing monitoring of the system. We had tools for debugging in production, not recommended. And one of the things I really like about StackDriver is that it does all of those things for you. There's one login, you get all those features. You have monitoring, you have your logging, error reporting, alerting. And you have tracing, and it works cross-cloud, which is one of the things I really like. So if you're on Amazon currently, moving to GCP, you can have stuff tracked in both places. Maybe you've got some systems in GCP and some systems in another provider, you can do that too. And because I'm here at I/O, I need to tell you all flat out, all this stuff is currently in beta. So hopefully my demos will work. So of all the apps I've worked on, one of the big milestones that went along with going to production in some form, whether that was our private beta or public beta or actually launching, was we had to get monitoring set up. We had to know, once people who weren't our friends and family were using our site, we had to know that the site was up, and that if it wasn't up, we were going to find out about it. And when I was doing this, I said earlier, we had 3 monitoring systems. We had a monitoring system that worked on our Rails stack. We had a monitoring system that worked on the system level and tracked things like disk usage and CPU. And then we had a third monitoring system that its only job was to make sure that the site was still up. And it just pinged the site every couple minutes, all day, every day, and would alert us if stuff went wrong. But we didn't write the best code. Or I didn't write the best code. Let's just say that. And sometimes we'd have a really bad day on the internet. And we'd have tons of errors that would be coming from all different systems. I would have no idea what was actually wrong. Did a bug in the Rails app fill the disk up? Or did the disk filling up cause the Rails app to crash? And with having all those alerts in different systems, it was really hard to get a holistic picture of what was going on with the site. And so StackDriver can do all of those levels of monitoring: application level monitoring, system level monitoring, and your uptime checks. And about uptime checks, I always, when I've been launching sites, this is one of the first things we do, and I always just set it up to check a simple URL. Hey, is that still there? Sometimes I have it checked to see if there's specific text on the bottom of the page. StackDriver does this great. And of course, you can also do things like check a given port. You can check a specific subpath. If you've got perhaps you have a microservices architecture and you have different subpaths or different paths on your site that are served by different applications, different parts of your application, you can check all those independently. And one of the annoying things is that I've found bugs with these uptime checks. I've found multiple bugs at every single company I've worked at with an uptime check. I found partner integrations that went sideways because someone updated their API without telling us. I found a disk that was full and the system level monitoring went sideways. And so this is something I really feel passionate about, and especially feel passionate about the fact that it's very, very configurable. So I can have as many of these as I need to feel confident when I'm monitoring a site. And uptime checks wouldn't be useful if you couldn't get notified when stuff went sideways. So lots of different ways to get notified. You can get notified by email. You can get notified by SMS. If you use something like PagerDuty, that's supported too. You can also do HipChat or Slack or Campfire if you use one of those for your group conversations already. If you have the Google Cloud Console mobile app, you can get notified there. And there's a webhook, so if you want to hook this into another notification system for your team, you can do that as well. So now we've got an uptime check. Next step, I'm a dev, so what I care about is knowing if this awesome thing that I built is actually working, preferably before the ops folks figure out that it's not. So let's do some application level monitoring. So I build a lot of my stuff using off-the-shelf and open source tools. I use Node, I use Rails, I use Nginx, I use Apache, Mongo, MySQL, Postgres, done some stuff with RabbitMQ. And all of these things are supported. If you have the monitoring agent running on your instance, you change one config file, you restart the agent, and you programmatically get support for things like inserts, updates, and deletes with MySQL, message queue statuses with RabbitMQ. You get request stats with Nginx, and all of that's supported, and turning it on literally takes less than 5 minutes. And even cooler, if you're running in GCP, running in Google Cloud Platform, we do some auto discovery for you. We check and see what ports are open on your machine. We check and see what services are running. And we can even look at the instance name and try to guess which features you want. I spun up a MySQL cluster that you're going to see in a couple more slides. And I spun it up cross-cloud. It's an EC2 and GCP, doing replication across. And on the GCP side, it's like, oh, you called this MySQL, and it's got the MySQL daemon running. So we're going to turn on the MySQL monitoring for you so that you can pull in stats on that automatically. You don't actually have to turn it on. It was lovely. Wonderful, wonderful surprise in getting the demo together. But you might be thinking, hey, my stack isn't on that list. Great. You can do custom metrics and monitoring. It's really straightforward. There's great tutorials to walk you through what format you need to get stuff in, and it'll monitor that for you. And of course, since this is Google I/O, and we're talking about Google Cloud Platform, there's integration for Google Cloud Platform. On App Engine, we pull a lot of these things in automatically. We did the same with Container Engine. On Compute Engine, we do the auto discovery I just talked about, and installing the agent is very, very simple. So I'm detecting application errors, I hope. I can also detect latency. Every app I've worked on, there's been a couple endpoints, but those were the health check for the app for me. If those were responding quickly enough, customers were going to have a good experience. And if those weren't responding quickly, I was going to start getting phone calls. And so you can do latency monitoring on App Engine. And one of the things I really like about this is that you can look at the average, which is what a lot of other tools support, but you can also look at the 95% case and the 5% case. One particular app I worked on, we ran 98% of our traffic through one single URL. And most of the time, 97-ish% of the time, it responded in less than 100 milliseconds. And it needed to. That was really super important. Otherwise, everything was going to feel very laggy. But one time or 2 times in 100, it would take up to a minute. We knew why that was. It was a particular edge case through the code. And we decided it wasn't worth fixing. But those outliers were pulling our latency stats way, way down. And so being able to monitor the 95% case would have been much more helpful for me, as the ops engineer and the QA person, trying to make sure that we were doing the right thing. And of course, if you're using App Engine, you can monitor either your whole application or just your modules. And you can also monitor by response type. Maybe you don't care if your error messages take forever to render. Or maybe you do want your error messages to render quickly because you want to fail fast. All of that you can monitor your latency on. So I've talked a lot about application level monitoring, system level monitoring. This is the stuff that I personally sometimes think is boring but necessary. You have to have it. You have to know if your disks are filling up. You have to know that you're using your CPUs efficiently. So of course you can. You can monitor your disk usage in I/O. You can monitor memory usage in swap, CPU usage in steal. You can see what your processes are doing, how many are running, sleeping, zombie processes. You can monitor your network traffic and OpenTCP connections. All of this stuff is available. You can see it on the dashboard by default, and it's all stuff that you can set alerts up on if you want as well. Some of these metrics are only available by installing the monitoring agent, but the monitoring agent is really simple to install. I installed it on a bunch of different servers this weekend in less than 10 minutes. And who here uses Chef, Puppet, Ansible, one of those tools to do their deployments? You can also install it with those. There's instructions on the website. And I've already talked about this a little bit, but yeah, it works cross-cloud. So if you're in a variety of environments, you can have all of your metrics come to one place, all of your monitoring come to one place, so you don't have to manage multiple logins to multiple services to see how your whole system's running. So I was talking a bit about how certain things are monitored, and I mentioned something about alerting, but I didn't really get into what that looks like. So certain things are monitored, but no alerts are set up by default. But But it's still useful because you can see the dashboards that we have set up to check how your system's doing. And there are default dashboards for services like MySQL and NGINX. There are also default dashboards for things like App Engine, Compute Engine, and Container Engine. And these are just our best guess at what you want. You can customize them as you need for your workflows, your team, what's interesting to you, the particular errors that you know your app has that you want to keep an eye on. All of that is available to you to monitor in different ways. So here's some examples. So in the center there is the App Engine response counts by type, by code. We have uptime checks on the left. You can see there's a little green circle, maybe you can see. And that's saying that the uptime check is passed on the most recent pass. You can see they have different groups. There's some information about CPU and block storage, and then at the very top you can see the current list of incidents. Luckily, there were none, so it gave me a green check mark. And here's a Container Engine dashboard. Looks largely the same, but you can see the GKE container CPU usage on this one. The GCE CPU usage, Container Engine is built on Compute Engine. Block storage is also listed. This particular app doesn't use it, but I'm just showing you the default dashboard off the what you get if you just go straight into monitoring after you've launched your app on Google Cloud. So lots of interesting stuff, and we showed this to you by default. But that's not interesting because I just showed you static pictures of demos, so let's actually do the real demo. This is the part where I get to be slightly scared. So I want this tab. So let's just look and see what we get. So this is for a MySQL cluster replicated between AWS and GCP. There's also an App Engine app running against it, but they're not hooked together. So I've got my CPU usage on both GCP and EC2. You can see that I had some incidents over the weekend that I resolved. That was as I was getting these things set up. And I can do things like go here to resources, and I can look at the MySQL stats. And so this is a dashboard for MySQL. It's got showing me some things here. I've got a bunch more. So you can see that I'm in my 2 different zones, and these 2 machines are running in 2 different cloud providers. They're all listed together. The health is all there together. I can see my stats on all the machines side by side, just like they were running with one cloud provider, and I was using that cloud provider's native tool set. And I want to show you some of the alerts I have set up just to really drive home the kinds of things that you can do. So I've got 3 different sets of alerts. Each of these has 2 rules. That's one for the GCP side and one for the AWS side. So the first one is network monitoring. So network traffic above a threshold for 15 minutes, that's one of them. I'm checking that on both AWS and EC2. There's a disk usage one. The disk usage is increasing too quickly, I want an alert. I don't want to know when it's full. I want to know when it's heading towards full so I can solve that problem before it gets full. And then the last one is I'm also tracking the MySQL inserts. It happens to be that I'm not actively inserting anything to this database right now. But if I have a certain number of inserts either over or under a threshold for a period of time, it will alert me. So I can use things I know about my system to figure out what the envelope edges of my system are when I want to know when things are going wrong. And all of those, there's 2 rules. The same alerting policy happens. And if I want to do something cool, I can show you, I can edit these. Oh, maybe? Yes. Yay, internet. So here's the EC2 rule. Here's the GCE rule. I can add more conditions if I want. I can change my notification method. And I can also include some documentation, which is something I really like because I eventually finally got permission to start passing off application level monitoring to the dev team. But sometimes they would get an alert and their first thing to do is pick up the phone and call me because they didn't know what to do. And here I could put some hints, such as if you get this alert, try these commands. These are the debugging steps. Go to this web page on our internal site. And once you've exhausted those steps, then you can pick up the phone and escalate to level 2 support. So that's awesome, and you have some monitoring. And we're probably all very excited about that, but not actually all that interesting in the long term because that just tells you if things are going wrong. What if you want to know about the current state of your system right now? And that's where logging comes in. Or you want to know what's happened. Maybe you want to know how many purchases you've had or how many critical errors you've had. So again, cross-cloud. You can run this on AWS. You can run this on EC2. Sensing a theme here. This agent, the logging agent, is installed on App Engine for you. You can install it on any of our other services. There is some support for logging on Container Engine as well, out of the box. And you can also use Google Cloud Logging API to stream events directly from your application. If there's particular events that you want that are in your application, you can stream those in. I've done things like this before to record purchases, record chargebacks. If we get into the error handling code and I'm handling an exception, I'll sometimes write out a bunch of additional user state into the logs at that point, and then let the exception actually cause the 500 error, just so that I can have some better idea of what's going on. Once you have the logs in our system, you can browse, query, and filter them in a web interface that I'll show you in a second. And you might be thinking, well, my issues are too complicated. I have too many logs to use the web interface. That's great. You can export it to BigQuery. And BigQuery was designed at Google for use with filtering, aggregating, and understanding logs. So it's really, really good at it. If you know SQL, you can use BigQuery. It's amazing. And it's really fast. I've thrown lots and lots and lots of data at it before, and it goes very quickly. So logging demo. Haha. So one of the first things I want to show you is that you can filter by log level. So if I do any log level, I have just a whole bunch of regular log lines. And this is largely pulling from syslog right now, but it's also pulling from my application log. The application here is a Rails application running on App Engine flexible environments using our logging gem that hooks you up to Google Cloud Logging. And I can filter here. And I have a bunch of stuff about a routing error for a route that I apparently have not implemented yet. So I should probably fix that. I can look at all sorts of logs. I can look at a request log. I'm going to do any log level on that because I don't think I have any errors in the request log. I can live stream logs, or I can pause logs. I can look at a given date and a given time period. And you can look at a bunch of our different services. So if you're running a bunch of different services in the same project, you can also filter by which service. Whether you want App Engine, you can do this. You can also search if you have multiple App Engine apps. You can look at your BigQuery logs, Cloud SQL logs, Compute Engine, Container Engine. All of that you can look at this way. So the log processor is really cool. Oh, the other thing I was going to show was, let's do this. You can also search, pure text search. So this is a bunch of things that contain the string 500. You can also do searches. So there's the 200. I can do searches, show matching events. So show me all the events that cause the 200. Apparently there weren't any. So lots of different things you can do to slice and dice logs with Google Cloud Logging. So now you've got your logs. You found that critical error that I had there. How do you deal with that? Especially if you have a bad day on the internet. So I've worked on 2 apps that have DDoS themselves. I'm hoping that at least one person in this room has also had that really, really bad day. And our logs filled up so fast that we couldn't see what was going on. It was just stack trace after stack trace after stack trace. And what we ended up having to do is spend we rebooted the entire system. We spent 2 whole days writing scripts to parse those logs so we could get some idea of the errors. And all we were doing is aggregating the errors very quickly. And StackDriver Error Reporting will do that for you. It analyzes your logs as they come in, and it aggregates events and groups them together based on their stack trace, based on the URL, based on the error code they resulted in, and then it keeps a count of them for you. So you've had 12 of these and 1 of these, and oh, this one's new. Maybe you want to pay attention to that one. And every app I've worked on has also had some normal errors. They're the things that just continuously happen, even if you're writing good code, or things that you've decided not to fix. And when they're all aggregated, it's really easy for you to just ignore that, as opposed to having to see them in your logs and see the stack traces for them in your logs. And one of the things I really like is it can also proactively notify you. So you get one new error, it'll send you an email, or send an email to your team. You get another new error, or another instance of that error, it'll send you another email. And yes, it does have back off built in, so it will not spam your inbox if you are DDoSing your site the way we did. It will give you a couple of notifications, and then at that point it's like, you know something's wrong, go to the web page and see what it looks like. And again, for the people who've had a really bad day on the internet, like I have a couple times, there's absolutely no limit to the number of errors it can store. It stores the stack trace for a couple examples so that you have enough info to debug, and then after that it just keeps track of a count. So if you're throwing several thousand or several million errors, it's okay. You're not going to take error reporting down and lose your tool that you need in exactly the moment you need it. Setup. So there's 0 setup for App Engine, 0 setup with most of the StackDriver logging plugins. It's a simple API call otherwise. You can just call in and say, hey, I just had an error, hey, I just had an error, hey, I just had an error. And it will track those and count those for you. And we're going to see what this looks like. So this time I have an App Engine app running in, that's debug, there, that's error reporting. So this is a Python App Engine app running in App Engine Classic, not flexible environments. And you see I've got a basic error here. I'm gonna click on it. It was a badly formed import. So it's happened 7 times. I saw it in version 1. It was a 500 error. It was first seen 2 days ago and last seen 2 days ago. So you've got some basic info about when it started happening, so hopefully you can track that to a version or a change. Here's the graph. And here's a sample. And there's a bunch of different samples, but I can also click here, get some more information. I can look at some raw data. And thank you. This is what I get for not mirroring my screen. And if that isn't sufficient, you can also go directly into StackDriver logging and see the request logs that went along with that error so that you can debug better and more efficiently. And so that's all the log information that went along. You can see that it was a critical error. So, debugging. You have an error, you need to fix it. And who here has debugged a site in production before? I'll own up to it. Yeah, I have totally hooked the Rails console up to the production database multiple times, and I've also caused people's browsers to time out because I threw a breakpoint in on a production website. And I'm not proud of this, but I have done it. And enough of you raised your hand that I feel like I'm among friends. So there is a better way. We have a live debugger in StackDriver. It doesn't add a significant amount of latency. Around 10 milliseconds is what they say. And instead of actually letting you step through the code, it's adding a watch point. And that watch point, what that's doing is it's taking the status of your application, the variables, the call stack, at a specific point, and saying, here's what was going on at this moment for an actual user on your website. And frequently, that's all I want. Frequently, I'm doing print line debugging on the live site by throwing a whole bunch of extra stuff out to the logs, when I could just say, tell me what's going on this line 3 lines before the exception, and then I can hopefully, from that information, figure out where I went wrong, what went wrong on my site. So in order to do that, you're thinking, well, how does it do that? How does it have access to my source code? There's a couple ways you can hook it up. You can point Cloud Debugger at a cloud repository, if you have that up there. You can upload your code to our Cloud Debugger. You can run it against your local code, which is what I've done, and that's awesome. Or you can just say, this file, this line number, and let it go. You don't even have to use the interactive interface that they have. So I'm going to, languages and platforms, right. So this isn't supported on all of our App Engine languages quite yet. It's currently supported in Java and Python for App Engine Flex, and Compute Engine. Yes, okay. And Go applications running on Compute Engine. And support for Node.js is in alpha. I know some people who've used it. It looks really cool. I haven't had a chance to play with it yet because I've been working with Python and Rails. So here's what this looks like, and if I have a couple seconds, which it looks like I will try to do a demo. It's a little bit hard to demo this because I can't make things big enough and still get everything on the screen. But the center there is my code. On the right, I have my list of snapshots. I set a watch point at line 21 of main.py. I can put a condition or an expression that I want evaluated. If you've ever used an IDE where you have your little watch window, same idea. And then underneath that is the set of variables that were active at that point, and I can get the values for all of those, and also my call stack. And so I can see what the call stack was to get me to that point I set the watch point at. Maybe this won't be quite enough to get you there, but it hopefully will at least be enough that you can reproduce the bug on your local environment and actually fix it. Or maybe you can write the test that you can then use, fix the test, and you can fix things that way. So, some photo credits. Yay for Creative Commons. I want to say thank you to all, and I have plenty of time for questions.